Hello friends, in this video I will solve one problem on Fourier series. Your problem is find a Fourier series to represent x minus x square from x is equal to minus pi to x is equal to pi, and deduce that 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square plus so on, its value is pi square by 12. Now in this problem, let f of x is x minus x square. It is defined in the interval minus pi to pi. If you will see the length of interval 2l in this case is equal to what? 2 pi. It means value of L is pi. Therefore, its Fourier series for the function f of x, it will be a0 by 2 plus summation n varies from 1 to infinity an cos of nx plus summation n varies from 1 to infinity bn sine of nx. Now we need to get the value of a0, an and bn by using Euler's formula. I can write the value of a0. a0 in this case is 1 by pi integral minus pi to pi x minus x square dx. This is equal to 1 by pi. I may write directly. This is x square by 2 minus x cube by 3 minus pi to pi. On solving this is pi square by 2 minus pi cube by 3 minus pi square by 2 minus minus plus pi cube by 3 . This is equal to 1 by pi as it is. If you will open the brackets, see this pi square and pi square will cancel out. I will be left with minus 2 pi square pi cube by 3. This and this will cancel out. Your final result will be minus 2 pi square by 3. So value of a0 is minus 2 pi square by 3. Similarly, I can find the value of an. Now the formula for getting the value of an is 1 by pi minus pi to pi. This is x minus x square is your fx into cos of nx dx. Now one of your function is algebraic, another is trigonometric. If I use the formula, this formula u and v, u is first function, v is second function, I can write its integration as u as it is, integration of v1, v represent it as v1 minus derivative of u, again integration of v, double derivative of u, again integration of v, minus triple derivative of u, again integration of v, so on. We will move till we got 0 as a first function. That's why we used to take algebraic function, this function as your first function, because one stage will reach when its derivative will get 0. Now on the same lines, I can expand this integral. 1 by pi is there. Derivative, first function is x minus x square. Integration of cos is sine of nx by n minus derivative of first is 1 minus 2x. Again integration of second minus cos of nx by n square plus derivative of first is minus 2. This is minus sine of nx by n cube. Lower limit is minus pi, upper limit is pi. Now, you know, sine of n pi is 0 means this term and this term. In both the cases, when you will substitute upper limit as well as your lower limit, they will get eliminated. So after applying the formula, see what I will get. Upper limit sine of n pi is 0. So your first term will get 0. Minus 1 minus 2 pi into cos of n pi. I will get minus cos n pi divided by n square. Last term, this is sine of n pi is 0, so I will get here 0. Minus lower term, again sine of minus n pi, sine of minus theta is minus sine theta, you will get sine of n pi, so this is also eliminated. Minus 1 minus 2 pi, cos of minus theta is cos theta, so I will get here cos of n pi. Even on substituting x as pi, I will get cos of n pi by n square. Last sign will get eliminated. Again I will get 0 for sine. This is equal to 1 by pi into minus this minus and minus, this will give us plus 1 minus 2 pi cos of n pi. Even from here minus minus and minus, I will get minus 1 minus 1 plus 2 pi. I can write cos of n pi by n square outside. So on solving, this term and this term will get cancelled. I'm left with 1 by pi into minus 4 pi into cos of n pi by n square. Pi and pi will cancel out, so your final answer is 4. Cos of n pi is minus 1 raised to power n by n square. This is the value of a n. Also bn is 1 by pi minus pi to pi x minus x square into sine of nx dx. This is equal to 1 by pi as it is. Let's apply the formula here. X minus x square, integration of sine is minus cos of nx by n square minus 1 minus 2x minus of sine nx divided by I should write here n. This is n. Here I will get n square plus minus 2, again integration of sine, minus minus plus cos of nx divided by n cube. Lower limit is minus pi, upper limit is pi. Again, wherever there is sine, when you will substitute upper limit and lower limit, your sign will get converted to 0. Upper limit is pi. See here what I will get. Pi minus pi square into minus cos of n pi by n. Second term will get 0. Second term will get 0. Third term I will get minus 2 cos of n pi by n cube. Upper limit. Minus lower limit, I will get minus pi square minus cos of n pi, because cos of minus theta is cos theta, n. Second term is 0 minus cos of, again I will get here cos of n pi, because cos of minus theta is cos theta. Let's solve this. 1 by pi This is minus pi minus pi square into cos of n pi by n minus 2 cos of n pi by n cube. If this is minus minus plus minus minus, I will get here minus pi plus pi square into cos of n pi. This is minus, outside is minus, I will get plus 2 cos of n pi by n cube. This term and this term will cancel out. There is by n. This is 1 by pi. Inside minus pi plus pi square minus pi minus pi square. Outside I can write cos of n pi by n. Pi square and pi square will cancel out. I will get 1 by pi into minus 2 pi cos of n pi by n. So your final result in this case is minus 2 into minus 1 raised to power n by n. Fine. So therefore what are the values? A naught, we have got its value as minus 2 pi square by 3. An is minus 4 minus 1 raised to power n by n square, and Bn is minus 2 into minus 1 raised to power n by n. So on substituting this value, these values in f of x, therefore your Fourier expansion is x minus x square is a naught as 1 by 2 a naught is minus 2 pi square by 3 plus summation n varies from 1 to infinity minus 4 into minus 1 raised to power n by n square cos of nx, n varies from 1 to infinity minus 2 minus 1 raised to power n by n into sine of nx. Further, this is minus pi square by 3 plus, I can write 4 outside. Inside we can expand the series also. N is equal to 1. It will give you minus 1 minus minus plus. I will get 1 by 1 square cos of x minus 1 by 2 square cos of 2x plus 1 by 3 square cos of 3x minus 1 by 4 square cos of 4x plus this. I can write 2 outside plus 2 outside. Again I can expand the series here. For n is equal to 1, I will get minus minus plus. I will get 1 by 1 sin x minus 1 by 2 sin of 2x plus 1 by 3 sin of 3x minus 1 by 4 sin of 4x plus 4, so on. This is my Fourier series for the function x minus x square in the interval minus pi to pi. Now further we have to deduce that 1 by 1 square minus 1 by 2 square minus 1 by 3 square minus 1 by 4 square and so on, their summation is pi square by 12. Their summation is pi square by 12. Further, to deduce the series, we need to select the value of x in the interval minus pi to pi in such a way that all cosines should get converted to 1 and all sines should get converted to 0. And the sign of